Hey guys, welcome to Flex. So what we're going to be talking about today is functions. And functions, it's a relatively simple idea, especially the stuff that we're doing today. So what I first want to do is I want to go ahead and define a function. And if you'll write this down on the paper that you also had, a function is a series of inputs and outputs where for every input there is only one output. Usually the inputs are X, but they don't always have to be. And usually the outputs are Y, but they also don't always have to be. And so what we're going to be doing today is we're going to be going through what a function is and looking at just a bunch of examples of how you can see what a function is. So we're going to be looking at tables and charts and graphs, and then at the very end, we'll talk about what the difference is between a linear function and a nonlinear function. So when we take a look at our inputs, like I said, there can only be one output per each input. And that sounds a little confusing at first, but if we take a look at our X values over here, the first thing I want to draw your attention to is that none of these X values repeat. So if none of these X values repeat, we automatically know that there's only one output for each input. If your X values repeat, that should raise a red flag for you. But for now, because there's only one output for each input, so at -12 it's 2, and at -10 it's 10, and at 0 it's -2, and at 5 it's -6, and at 8 it's -11, and at 15 it's -15. All of these are different inputs, and each input has a different output. So we can automatically know that this is a function. This one right here, let's take a look at it. So once again, our inputs are our X values. And if you take a look, I notice that this 9 right here repeats, and this 9 right here repeats as well. And so that raises a red flag. That doesn't necessarily mean that it's not a function, but it is going to cause me to do a double take. So let's take a look at our 9s. So for my first 9, that output is -18. Now if my second output is also -18, then it's fine, it's a function. So let's take a look at our other 9. Well, it's a 17. So that means that my input has 2 outputs, which is not possible for it to still be a function. So not a function. So once again, this is not a function because the 9 goes to -18 and it goes to 17, which means this input has more than one output, which is not acceptable for being a function. All right, let's take a look at this one. So once again, these are all of my inputs right here. All X values, they're all inputs. So if I take a look at this, I see a red flag. I see -3 here, and I see -3 here. So I automatically know that there's a red flag. Now, this is not a function if these -3's go to different places. So the first -3 goes to 7. So it could still be a function if my second -3 goes to 7. So let's see where it goes. My second -3 goes to 14 right here. So I automatically know that this is not a function because my X value of -3 has 2 different outputs. So this is not a function. So once again, just kind of look at your X values, and if you have more than one, it should raise a red flag, and if your X values are going to 2 different places, then it's not a function. Okay, let's take a look at this one right here. So we're going to perform something called vertical line test. Now remember, a vertical line is a line that goes straight up and down. And if this line that goes straight up and down crosses a graph at more than one place, then it's not considered a function. So let's draw some vertical lines. I've got a vertical line here, and you can draw these anywhere that you want. And so far, it seems like a function. until you get to about this point right here. When you get to this point right here, what you're going to notice is that this vertical line passes through this graph twice. And it does here too, and it does here as well. And because it passes through this line twice, it does not pass our vertical line test. So our x value of 1 has actually more than one output. So you see here that 1 goes to 3, but it's also showing that 1 also goes to -2. So this could not be a function. So if you have a graph in front of you and you want a really fast way to see whether it is or is not a function, if it doesn't pass the vertical line test, then it's not a function, which the vertical line test, once again, is if you have a vertical line that passes through your graph and it touches your graph more than one time, then it's not a function. All right, let's take a look at this one. Let's draw some lines. So if we look at our vertical lines, this one passes here once, 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 and once. So all of these only pass through the graph one time. So this actually does pass the vertical line test. So this is a function. Let's take a look at this one. Let's draw some lines. So this one passes through the graph once and once and once and once and once. So when we take a look at this, we can automatically know that this is a function because it passes the vertical line test. All right, let's take a look at these tables. So it's very similar to the above tables. Instead of it being up and down though, now we've changed to it being across. So still, our x values are our inputs. And we're gonna notice here that there are no inputs that are the same. I have -7, 0, 9, and 12. So all of those inputs only happen once, so I can know that this is a function. Okay, moving on. All right, let's take a look at this one. So once again, I'm going to look at my inputs, and I'm going to see that none of them are the same. So I'm automatically going to know that this is a function. Now, something that might have raised a red flag for you guys when you were looking at this is that there's two -7s. So you can have two different outputs going to this, you can have two different inputs going to the same output, but you can't have one input going to two separate outputs. So really the only thing that matters is the x values. You need to make sure that there's no repeats of x values going to different places. All right, let's take a look at these graphs. Once again, we're just going to do the vertical line test, and that's good, that's good, that's good, that's good, that's good. All of these are only crossing through at one point. So since they're all only passing through the graph at one point, we can automatically know that this is a function. Okay, let's take a look at this one right here. So we've got this one, this one, this one. Now, all of these, once again, are only passing through this graph at one point, so we can know that this is a function. All right, let's take a look at this one right here. Let's draw vertical lines. All right, so we have a bunch of vertical lines here, and what I'm going to notice is that that passes through there one time, that passes through one time, one time, one time, one time, one time, and one time. So all of those pass the vertical line test. So it is a function. All right, let's take a look at these right here. The first thing I'm going to notice is that there's no repeats of x values, so I'm going to know that this one is automatically a function. All right, let's take a look at this one. So off the bat, I notice that there is a 3 here and a 3 here. So this raises a red flag. So my first 3 goes to -5. If my second 3 goes to -5, we might be fine. However, my second 3 goes to -1. So I have one output going, I have one input going to 2 different outputs. So this is not a function. Okay, let's take a look at this one. So I have the outputs of 7, 9, -6, and 1. Now, none of those are the same, so I can automatically know that this is a function. All right, let's take a look at this one right here. So we're going to do our vertical line test. I'm going to draw it through the points this time so that I can see it. All right, so right off the bat, I notice that this vertical line passes through here and here. So since this vertical line passes through 2 points on this graph, this is not a function. All right, let's do this one. So this one right here crosses through this here and here. So since that vertical line passes through twice, I know that this is not a function. All right, this one right here. All of these only pass through one time. So I know that this graph right here is a function. All right, so this graph right here, I want to go back to this one for just a second. So if you guys remember from when we were talking about slope, when you have a horizontal line like this actually means y equals some value. Let's say 4. So here, we have a horizontal line, and this line is actually not undefined. So our slope is not undefined here. Our slope is just 0. And the reason why I wanted to talk about that real quick is just because we're about to go on to this one right here, where we have just a straight up and down line. And just as a reminder of what it means to have a straight vertical line, is it means that we have x equals some value. So I'm going to say for this one, x equals 3. Now for this one right here, this means we don't have a slope. Our slope is completely undefined. And while it's not super relevant to the vertical line test, it is something I just wanted to discuss and remind y'all of real quick, is what slope is and what the slopes of these graphs are. So this one has an undefined slope. And this one has a slope of 0. Okay, so I drew a vertical line right on top of this vertical line. And while this might not immediately raise a red flag for you, I'm going to go ahead and highlight all of the points where this intercrosses back over that other line. So it literally just keeps repeating on top of this line over and over and over again, right? So it doesn't cross through just twice or something like that. It crosses through over and over and over again. So this does not pass the vertical line test at all. This is not a function. So anytime you see a vertical line inside of a graph, you're going to automatically know that that's not a function. So let's take a look at this one. Going off of what I just said right there, I see a vertical line right here. So it's not passing this test at all. It crosses through all of those points just over and over and over again. So this one is not a function either. And then last but certainly not least, we have this one right here. And you'll notice that this one only crosses through one time. So this one is a function. Okay, the next thing that we're going to talk about is linear functions versus not linear functions. And just because it's not linear doesn't mean it's not a function. Something that is not linear means that it has a curve in there. So something like this. And when it's linear, that means it's just straight. So something like this. Right, so if it's curvy, then it's not linear. And if it's straight, that means it is linear. So what makes something linear? Well, what makes something linear is when we have an exponent of 1. And that is attached onto our x value. Okay, so it needs to have an exponent of 1 attached onto our x value. And essentially what that means is that first you see an x, and second, it might mean that you see no exponent. And this is typically, I mean, sometimes they might say exponent of 1 right next to that x, but typically you'll see no exponent. So let's take a look at this one right here. I am looking at my x, and I see that there's no exponent, which means that there's actually an exponent of 1. So I know that this is a linear function. This one right here, I know we haven't really showed how to do something that has the exponent of 2 right here, but just know that this is going to distribute to here. And it's a little bit complicated about how that distributes to there, but it is going to distribute to there. So that means that our x actually has an exponent of 2 there. So we know that since it doesn't have an exponent of 1, that is not linear. All right, this one right here has an exponent of 2, and so that's not an exponent of 1, so that means it's not linear. This one right here has an exponent of just 1 right there, so we can say that that is linear. This one right here, the exponent of x is just 1. Now, if x was in the denominator, then this would actually have an exponent of -1, which we'll talk about later this year. But for right now, all you need to know is that if it's on top of the fraction, if it doesn't have an exponent attached onto it, then it has an exponent of 1. So that one's linear. And then this one right here has an exponent of 3, and that is certainly not 1, so it's not linear. All right, I hope you guys enjoyed this, and I hope you learned a lot. You'll be learning this on Wednesday, so yep. If you'll make sure that your name is on this paper and your math teacher's name is on this paper, and if you will hand it in to the teacher on your way out. All right, bye guys.